In this video, I'm going to show you how to use a densiometer. It's just one tool available to us as ecologists to sample along a transect. So keep in mind, it's a densiometer, not a densitometer. If you type densitometer into Google, you're going to get something that, some chemical device that measures the density of some substance. In this case, we're using a densiometer as a tool to measure the density of a canopy in your study boundary. So I introduced sampling in the last video, and in particular transect sampling. Keep that context in mind as I talk about how we're going to use a densiometer. So I said, okay, you take your first point, then you walk 10 meters, you take another point, you walk 10 meters, and so forth along your transect. Well, what does that mean to take your point? In this case, we're going to use a densiometer. This is where, just like you see in these pictures here, you look through the densiometer, you look along a very narrow, precise line into the canopy, and you see what that exact point hits, and that is your point. You're not taking a sample of the entire area of vegetation. You're not looking at this window here and saying, okay, at this site there is about, 50% cover. That is not what we're doing here. In this case, you're literally only seeing what that crosshair hits very precisely. So imagine you're looking at this with your eye, and you need to be able to identify what those crosshairs are precisely hitting in that periscope. Okay? I'll introduce you now to the densiometer. It's essentially half of a periscope. In a submarine, you have two mirrors. And that is so that the submariners, when they're inside the sub, can look into that periscope just like this gentleman is looking into this one. And then they would be able to move that around and see horizontally what it looks like, 10 or 20 feet above the submarine. So it can ride along under the water, and they can see around on the seascape there up above the surface. Well, in this case, it's half of that. It only has one mirror right here you see in this image. And that mirror is just at a 45-degree angle, and it points directly at the sky, and it has two levels in it. So when you're looking into this densiometer, by the way, this one is a very expensive one. It's about $220. The ones that we use in lab aren't quite so expensive, but they serve the same purpose. The only point is that it's accurate enough so that you're taking a consistent measurement every time to avoid bias. We're always trying to avoid bias in science, so that's what this is all about. Okay, so back to the level concept. So keep in mind consistency. When you have a level, you're trying to line that up so that it is perfectly straight. It's not leaning forward or backward. It's not leaning side to side. It's perfectly straight up. Now, you don't need to sit there and get it as precise as a carpenter would, but you need to sit there and make sure that the bubble is in between these two lines. Then you take your point. In reality, once you're a good ecologist, a good field ecologist, this would happen really quick. You would line them up, take your point. I'll explain that in a second. So just like he's looking here, you line your circle up there on this little piece of plexiglass with the crosshairs that are at the top piece of plexiglass. And that makes sure that, first of all, you're looking at the right spot in the periscope, and then you look at the levels to make sure you're lined up. You see what exact piece of vegetation your densiometer hits, and then that is what you would record. So again, you're not taking the whole sample. You're not saying, it's about 50% cover. You're saying, that's a valley oak. You move on. Take your next point. Hits a sycamore. That's your next point. Then say the next one, it's open. Like, see, there's some open sky in this image here. Let's say the crosshairs were hitting some of that open sky. You would record that as no hit or open sky. That's what you'll see in your data sheet that we provide you for Lab 6. So in this image, it shows you how that looks like. In theory, this is an infinitesimally small line, right? It's a point in space. Think of it as like a quantum singularity. However you want to visualize it,
it's just a very narrow line. There's no thickness to it, so that whatever it hits, it hits. It cannot hit multiple things at the same time. So let's say you're looking in an area that is multi-storied. So remember in CWHR lab, we talked about multi-storied stands. This is where that concept might actually come in the field. You're out there sampling, and you need to, understand that when you're trying to estimate percent cover, you might have a top canopy and a bottom canopy. There might be multiple layers there. Well, your line, it's infinitesimally small. It can only touch one thing at a time. So if your densiometer hits a leaf here on the bottom canopy, that's what you would record, even if there is another tree directly above that leaf. You hit whatever it touches here, and let's say you see your line almost seems to touch a point on the lower canopy, and then it touches a leaf on the upper canopy. Well, that's not possible. Again, when you're a good ecologist out in the field, you would be able to recognize which one of those it's touching right away. You wouldn't spend time on it, and you would move on. And part of the reasoning there also is that theoretically, you wouldn't be biased, and each time, let's say in a field, you come across a lot of situations where it's a toss-up between whether it hits the upper canopy or the lower canopy, it would even out in the end. You would have to choose one and move on. That's pretty rare, though. So what does this look like when you're actually walking along the ground? So in the last video, I introduced you to sampling, transect sampling in particular, which is where you would use a densiometer. You could also use a densiometer for random point sampling, but usually it would be for transect sampling. So in the previous video, I said, okay, take a point, walk 10 meters, take a point. In Lab 6, we're doing 2 paces, and that will be a more familiar concept by the time you're done with the end of lab, why we use paces. You're not going to sit there and walk along a tape. Usually that's not the case. As an ecologist, you would know you would just walk 2 paces. Your paces are about the same length, and you move on. So you take a point right here, and then you move along, take a point, move along, take a point. So to reiterate, when you take a point, you're not looking at the percent cover of that entire window. You're literally looking at what that exact line hits. Say it's Valley Oak, walk 2 paces, Valley Oak again, 2 paces, Sycamore, 2 paces, open, 2 paces, Valley Oak. You get the idea. Move through your site. That's how a densiometer works, and make sure that you integrate this into the context of sampling in general. If you need clarification or if you want more examples from your TA, feel free to ask.